Cecilia. Okay. Okay. Okay, let's start with Richard. You might have, you have class today?
Yeah, in about an hour.
Yeah, let's get you, no, present
Yeah.
first.
I mean, I don't have too much to present. The abstract for the cancer screening that I wrote for like my school, it was accepted. So I'll be making a poster for that and to present at the Louis Landberg thing in about a month. But yeah,
Okay.
besides that, I don't really have that much to present. I'm still waiting for the clinical trial results from the stats team.
So, yeah, tell me what project you're involved in, where you are, and what, what progress you've made.
Yeah, so for that one, I wrote the introduction already. And then I'm waiting for like the rest of the information to like, I guess like finish writing up everything
So
from it.
that's the adenoid cyst. Is that the adenoid cystic?
Yeah, with the Nivo IPI.
Right. So what data are you waiting for?
From the stats team,
Uh-huh.
we asked them about like a few weeks ago for like any updates from them for the results and an analysis of the data. And they didn't reply yet.
So this is what you have to do every 3 days. If they don't respond, CC me and just kindly follow up. I know we want to know if there's updated data. What is there anything we can do to help you? You have to be because they're really busy. Same thing.
Hmm.
They'll try to reach me. I have so many emails to
Yeah.
respond to.
Okay.
Oh, I respond to the persistent follow-up emails. If they email me once and they give up, like I don't reply back.
Okay.
I
Okay.
have tons of other things to do. So
Okay.
here you have to be very persistent because these cancer center statisticians,
Mm-hmm.
so many work.
Okay. Hmm.
So and then always CC me that so that they know that I'm the one who is the one in charge.
Yeah. Okay.
You can say Dr. Che wants to, publish this as soon as possible, and then we want the most up to date. Because like the data that we have right now could be, 2-year follow-up, but then we can show it's 3-year follow-up. If we have any information gathered now as opposed to a year ago. So yeah, keep me in the loop, and once you have the data, be ready to write it up.
Yeah.
And then in the meantime, there are papers that's coming out on adenoid cystic. So discussion, introduction, you could, finish that part.
Oh, discussion too. Okay.
Yeah,
Yeah.
because discussion is going to be about what has been published before, has
Hmm.
any immunotherapy not be done in, adenoid cystic. Then you
Mm-hmm.
have to cite every single trial that is focused on ACC,
Yeah.
and then compare to these trials, our results show that, you need to discuss them anyway. So
Mm-hmm.
just get those things ready, because you have to write about it anyway.
Yeah. Okay. Yeah, that makes sense.
Okay, so you have that trial paper you're writing up. Anything else?
For the cancer screening review study,
Uh-huh.
we were kind of wondering if you had a time to look over the manuscript
Manuscript?
for it.
Yeah,
Yeah.
yeah, yeah. We should do that. So I know Juhi cannot make it today,
Yeah.
but this is being recorded and you're here. Who else is involved in that project?
Liam and
Liam
Arnie.
and Arnie? Okay. Yeah, so let's go over that. Do you have it in Google spreadsheet document, or where where is it stored?
Yeah.
I think it's already in the Google, already in the Google document,
Oh,
right?
send to me in the chat box and I will Oh. Wait, I cannot share screen. Okay, yeah, send it to me in the Google Doc. I have another laptop that I can use to share screen.
I think this is a link for it. It's the one that we sent over to you.
Okay, so is this done or is this still in the works?
It's a bit over the word count. But everything is filled out. All the sections should be completed, I believe. Yeah.
Okay, let me. I have a desktop and a laptop, and my desktop does not allow me to screen share for whatever reason, so I'm pulling it up in my. Okay. Let's use the. All right, I'm going to the chat box. Oh, can you resend it? Since I logged in. Hmm. Okay. Okay, I got it. So I'm sharing screen now. Okay. You see?
Yeah.
Okay. Is this the? I guess this is the abstract.
I guess I haven't written it yet, but I the one that I wrote for the research like thing at Northwestern is kind of similar.
Uh-huh.
We could kind of framework off that, but um yeah, it's not like written yet.
And this is the first full draft of the manuscript that we're actually able to show you right now. And this will be the first time we're getting feedback on the whole thing. So we just wanted to show it to you to get some input so we can proceed with the subsequent edits and drafts.
Okay. My suggestion is always write the abstract first. So that way it's almost like your outline. Don't try to save it to the last. Okay, introduction. Cancer. Is a burden. We need a prevention. Multi-cancer early detection. What technologies are being used. I would say given the recent commercialization, it's my well, I guess the multi-cancer early detection, I don't know what changed, but I think GRAIL is the only one that I know that's multi-cancer. There are colorectal cancer only, so I don't know if you can call it tests. So look into that. And this is a reference for the introduction. This is good. So the criteria is pretty detailed. Did not reach clinically significant conclusions. So there are, so if you study epidemiology, there are different biases, but there's a publication bias, selection bias, all that. I would say clinically significant implication. So whether it's positive trial or negative trial, if you don't think that's a clinically relevant design or study, then we don't include it. But when you say conclusion, it's like, it feels like you're only accepting positive trials and let go of negative trials. So that's a bias. So I would change that wording. I don't think we did that. We didn't select only the positive trials. So what does the colored sentence mean? Like, why did you color this?
I'm not sure. I think Eugene wrote that part.
Hmm. Okay.
I'm not sure either. I suspect it was just a way of highlighting her new edits, but I'm not sure what it signifies.
When studies had training and validation sets, reporting were some. I don't like the wording here. Reporting were some. Using data available in the manuscript.
Yeah, I think there's an extra comma, but they're just summing like the different groups when they report like sensitivity and specificity for different like cohorts in the study
Hmm.
to combine them.
So Richard, why don't you rewrite the sentence?
Okay.
Yeah, it doesn't read well. Did we ever contact authors to get more information? I think we did.
Yeah, we wait about
No?
Yeah, for
oh,
missing.
no, we did.
Yeah, Arnie,
I was getting mixed up with the rhesus definitions for a moment there. Richard, do you have any updates regarding that?
yeah, so this is from Arnie and I. We didn't get a lot of the information that we were looking for because it wasn't there, or they didn't reply. But
Did any one of the authors who, you reached out, reply back or none?
yeah, there were a couple of
Yeah.
yeah.
Oh, okay.
Actually,
Then,
at first there is a couple that reply, but it's only like 2 or 3 author, and after that they didn't reply anymore.
Hmm.
Usually.
yeah. So, and then if the information provided were used for this manuscript or no?
Most of it was for table 1. It's like a table where we wrote down like the percent male, female,
Oh, okay.
like how many people. Yeah.
Yeah. So so write that. So unpublished data were gathered, by contacting the corresponding authors. Yeah. So that's what we did. That it's not just based on the published data. So you should write that here.
Okay.
So here, true, positive, false, negative, and it was used earlier. So to follow the rule, whatever was used for the first time, gets the acronym, and then that acronym should be used after. Okay.
That's helpful. We're trying to cut down on word count, so stuff like that is good.
Yeah. Yeah, once you use TP here, then it has to be persistent. Every true positive has to be TP going forward. Yeah. I mean, this is always the case for many meta-analysis, and it's maybe especially for this one. But we don't have to write it out. Like we don't have to say we lack this. So comes from diverse studies. Using different platforms, different assays or something. And that really means that it's hard, hard to pull. Just say it, otherwise not say we're not precise, it just eats up our own credibility.
And I think we already say it in our limitations in the discussions. I don't think we have to say it here again.
Right. This is not evaluation of our method. This is just describing what we did. Yeah, you don't have to say however, just say we did this. Extract the data. Maybe we were not able to get extract the data. I don't like this expression. Let's think about something else. We were not able to get the raw obtain the raw data or raw statistics.
Or do you want original data?
Original maybe a better word. Yeah. Original data required to run meta-analysis or something. This is also an evaluation of what we did. So you don't have to say it here. You can bring that into discussion or
So if we think that particular sentence is just talking about the inclusion and exclusion criteria of the article selected, do you think it should stay, or do you think it should still be removed and put in the discussion part?
this is still method. Well, so this is actually result. This is part of the study result that we, the method is we're going to screen and look at these database. And then when we actually looked, we found this article and then we, it's a little bit tricky. See what other meta-analysis papers have done. Like, did they describe all this in the method? So I think it could be either one, but look at the recent meta-analysis papers, see what they've done, just follow the trend. So 4 different groups. One is methylation, whole genome, blood cell extraction, and others. Now, I think the reviewer might ask why there's overlap. cfDNA methylation, and there's a cfDNA methylation here. Do you know why you've done it this way?
Oh, I think that was a typo. We meant to write like methylation and then just like looking for mutations for the other one.
Okay.
Or yeah.
Whole genome sequencing is part of the sequencing platform. Not every assay will do whole genome. And usually whole genome is done to evaluate copy number alteration. Anyway, you have to take out this methylation based. And I don't know if you have to emphasize whole genome here, because it's the second category. If you have anything that's sequencing less than whole genome, you can't put it here. You know what I mean? It's more, you're looking at, so I would more like methylation epigenomic versus genomic sequencing and epigenomic sequencing. That's another way to look at it. But methylation base is the widely accepted terminology. And then I would say cfDNA mutation-based assays. That will cover whole genome and everything else. And be consistent in using that terminology all throughout the paper.
Mutation-based assay.
Yeah. That's cfDNA. So this is CF, CT. And I think at some point in the method or somewhere else, you have to say why you are using this two different terminology, CT and CF. At some point, before you just start using two different acronym, I would say circulating. It's usually circulating cell-free DNA, not just free. Cell-free. Circulating cell-free DNA includes DNAs from the host, non-tumor DNAs, versus CT DNA, is saying that I'm only looking at the tumor-derived DNA. So cfDNA is the right terminology if you're looking at germline as well as tumor DNA. And any copy number analysis, you are looking at cfDNA because you are looking at the germline, which is your normal cell DNA copy number versus the tumor copy number. So you're looking at both. Anyway, just be aware that these two terminologies are different and say why you are using it differently, and don't use it interchangeably because they're different. Because right now, here it says cfDNA methylation, and here you say ctDNA methylation. So we usually say CT, because we don't check methylation patterns of the normal cells. So it's usually CT. So here, most studies were case control studies and screening tests that utilized majority. So 9 and 1. Is that CF, CT? I don't
Yeah.
know.
I think Eugene went back and looked at the studies included in the meta-analysis and looked at if they wrote down CF or ctDNA for their articles.
Oh, that's not a good way because some companies would use CF, meaning CT. So that's a bad way to categorize. I think the best way is for the, in the introduction, you say what's the difference in the terminology. What is cell-free DNA? It's any DNA, including tumor and a host DNA. And then say ctDNA is used to describe only the tumor-derived DNAs and sequencing of that tumor DNA and comparing that to the host normal DNA, sequencing or the comparing the copy number of that methylation of that to the normal DNA shed in the blood. That's kind of the gist of the technology. And for the purpose of this review, because most technologies are comparing ctDNA to non-tumor host or germline DNA, we will be using the terminology CF, which includes ctDNA. You know what I mean? You just say that out first, and whether the paper uses CT or CF, just use CF all throughout.
Okay.
That way, because it's it's a little bit blurry.
Yeah, but it's like impossible to only use ctDNA in like an assay to like isolate it before you like.
Yeah.
Yeah.
And all the et als have to be italic, so just go back and do it for Chen et al, like everything else. So I'm looking at the structure.
Yeah, so from here on down, it's the old version, so you don't have to look at this.
So is
The discussion that says new discussion with the purple highlight is the discussion section.
okay, so this is in the results. So I like it in the result, but check with other meta-analysis paper. So this is the first result, ctDNA methylation-based cancer screening assays. So, whole genome sequencing based. So methylation. And this is all whole genome, I guess.
This is like looking for mutations and DNA fragmentation patterns. So we want like a name to like unify like sequencing of the DNA fragments, ctDNA,
Hmm.
in different ways, but to look at cancer.
Hmm. So I guess the first one didn't look at just the DNA, but also protein markers. And these numbers are coming from the combination screening.
Yeah.
Then you can't say similar approach. Yeah, I don't think this used protein, did it?
I don't believe they did.
Yeah. So you can't say that this result is coming from sequencing alone because we don't know what protein biomarkers have contributed in increasing the prediction, right? So in a more purist view, this has to be in a combinatorial approach. Although this is whole genome, I think this should go last. And just describe pure performance of the whole genome sequencing, and then say when it was combined with the protein marker, it showed this, you know what I mean? That's the better logic. So cfDNA fragmentation pattern. So that's called fragmentomics. So whole genome sequencing based. Another abnormal genetic marker, dysregulated profile. So circulating DNA fragmentation pattern. It's used in many platforms now, but I guess one that's introduced here is one article.
Yeah.
I guess Gardens or Freenome, all these companies been using it, but they're only doing it like single cancer platform. Um, it's hard to believe that there's only one available to analyze for multi-cancer. Do some background check. Fragmentomic this paper, make sure this has used whole genome. Sometimes they don't. Make sure, same thing with the 5-HMC method, make sure they did the whole genome. If not, none of the, if any one of the papers mentioned here didn't sequence whole genome, not talking about whole exome or hotspot, I'm talking about really sequencing the whole genome, then you shouldn't be titling it WGS. It has to be just mutation based. Okay. So make sure. cfDNA based multi-cancer screening. when you say supplemental figure, you don't have to say C and D, to say figure 1. And they will find it. This is, I know there's so many figures, but you don't have to be that specific. Same is true for everything else. Let's say cancer types here. So blood cell extraction based. So DNA methylation, but it's from peripheral blood mononuclear cells. So I'm trying to understand this paper. The methylation happened in host mononuclear cells.
Yeah.
And here you say detect hypomethylated cancer samples. What does that mean?
Like cancer patients had these PMNCs that had an overall like lower level of methylation across their entire genome compared to like healthy control peripheral blood mononuclear cells.
So I think you should change this. When you say hypomethylated cancer,
Mhm.
sounds like the cancer is hypomethylated.
Oh, okay.
Yeah, or you could say the hypomethylated PMN, you know, PMNs, in cancer samples or something. So this microRNA molecule is also in the cell, but they can be circulating in the blood. So they, I mean, cell extracts are also, I guess, cell extraction. It's like you have to extract it from cell, versus microRNA is kind of everywhere. Mm. Yeah, so this, I'm not sure meta metabolite biomarker. I think you have to give an example of what they are, like what are they measuring? And metabolites are, what are those examples? Like what are they actually measuring? Trying to figure out, blood cell extraction and other how they can be different.
Yeah, for the blood cells, in their methods, they all like extract like the cells first and then like only take the like DNA, for example, from those like isolated like platelets or
Right.
blood mononuclear cells. Do you think we should specify that more in that section then?
I think either, yeah, it either right up front, this paragraph, say why we specify this group as, one category.
Mhm.
Anything that undergoes, extraction from one specific type of cell, the extraction process versus just, detecting anything straight from the blood.
Okay.
And this other cancer assay should be other non-cell based or something, so that that they're different. So this is mass spec, measuring metabolites. This is microRNA. So you say, non-cell extraction. To belong to this category, it's not cell extraction based, and it's not DNA based, because we had DNA methylation, DNA mutation, right? And then so non-DNA based,
Yeah.
non-cell extraction based. Goes, and then they include, just don't go too much in details, from the first paragraph. Just describe what this group is first, and then, in this group there are metabolites, microRNAs, microRNAs, proteomics, all that is here. Okay. So you get the tables. Is discussion done?
Yeah, that's a new version of it.
Okay.
Up to here.
So is it the last paragraph,
Yeah.
or are you still working on it?
Oh, no, it's done.
Okay. I guess this is almost writing another introduction. But it's okay. This is like, our review is valuable because it's the first in the field. Necessary or breast cancer is, what does that mean? I don't know what you were trying to.
Yeah, I think she meant that like breast cancer in particular needs additional detection because it's poorly picked up by the ctDNA based assays. But we can definitely reword that.
Yeah. So it's not just breast cancer, but also any tumor that is known to have lower shedding rates. ctDNA alone is not an ideal platform.
Mhm.
Say that. And also, I don't know if you mentioned in the back, something like glioblastoma, where there is CSF blood-brain barrier. It's always a challenge. Unless you do spinal tap. So I think if when you mention shedding rates, always mention the CNS tumors.
Okay.
I mean, it says there's different platforms, but DNA is the dominant one, and by DNA, breast is the inferior has the inferior outcome. So cfDNA chemistry showed higher than sensitivity. Outside the US,
Yeah, there are a lot of studies from like China, Europe, like different Asian countries.
I don't know if this is a strength because most reviews do that. You know what I mean? This is like the norm. Everyone does international cohort, so I don't think you should write that. I would also say this is the first meta-analysis. Not just the review. It's a strong word, impossible. You say impossible, it's like they're gonna like, why did you write this paper then? I just say difficult. So unable, so think about it. Controlling for the variables. And like you can't control, I guess. I mean, effective controlling only happens with randomization. Without randomization, it's going to be, multiple logistic regression, which is not gonna be possible because we don't have all the data. So different technology doesn't mean you have to you can control for all of the variables. It's a separate issue. To control for other variables, you need to have all the other variables. like pathology, demographics, and you try to because they're all different cohort, you can adjust for, control for other variables. But if your one is using protein, one is using DNA, it's not issue of controlling it. You know what I mean? So I don't think you should write these two together. Controlling is difficult because they use the cohort they used are different. Some use men only, women, cohort, some, different age cutoff. So they're not exactly the same cohort, so it's hard to control it. So in other words, there's a high level of heterogeneity between cohorts. So it's hard, making it difficult to control for other variables. So that's one issue. The other issue is that the essay platform is different. So you cannot and you should not pull it. You cannot do meta-analysis if you're not using the same biomarkers. So that's sort of the theoretical perspective, but practically, no, we still want to do, kind of compare their performance by types and kind of pull everything together, still understanding that we're not allowed to pull, but we're just doing it anyway to look at the trend. So that's two different issues. So write that separately. So this is not a limitation because we said this is the scope of our paper. So don't put it in the limitation. It's part of it's just our direction. This is what we chose to do. I would say this is the largest beta. Now I would say, something here of note, we intentionally did not look at the single cancer, something like that before getting to the limitation. Like this is for the multi-cancer most comprehensive review. For single cancer, this is not our scope of it's not covered, and that's not considered to be limitation. For that, we need to write a separate paper. Third, it includes 10 case control studies which cannot provide accurate information on incidence and may not be applicable to general population. Imprecisions. Funding conflicts. This is what we call COI, conflict of interest. I mean, if it's paid by the company, the paper is going to write favorably about the technology. Funding conflicts. Is that an existing terminology, Richard? Funding conflicts?
Not exactly, but yeah, we just meant that maybe a study group is supported by a company that made the assay they're testing or something.
So all these are potential, possible biases.
Yeah.
It's like possible or potential. If you write it like this, it means that they do contain, we're saying there is one, there is a, it's right, possible potential. The review maintains the bias. I don't, imprecision presented by. Additionally, there are always, for as with any meta-analysis, as with, I mean, these are biases that are created, biases coming from the individual papers that we reviewed. These are not our, like our review, our paper is not, doesn't have potential funding conflicts. We're not paid by someone. We're not loyal to some company, okay? So this is not necessarily a limitation of our review paper. This is a limitation of any, any clinical trial. It's severely affected by who funded the study, like pharma, okay? So I'm not sure if this even is relevant for paper. And this is like just, epidemiology 101. If it's not something that we are concerned about our own review, I don't think we should write this.
Yeah, I think we're just looking for limitations to include, but
Yeah,
yeah, if it's not super relevant, then we can take it out, make it shorter.
and case control studies are not designed to look for incident, right? So this is not a limitation. This is this is how the epidemiology studies are. May not be applicable to general population, of course, because it's a case control study. Only the population-based studies are, going to be able to give you incident and have some applicability or generalizability. So I don't know if this even makes any, like, is a limitation. With case control study, you can still look for sensitivity and specificity. That's what we want. And that's good enough. You could say limitation is there were more case control studies than population-based studies. But the purpose of our review is looking at the performance of the assay, not looking at the instance of cancer. So this is, to me, this is not limitation of the study. This is how the epidemiology studies are in real life.
I think the limitation we were trying to get at was that like this screening would be ideally for people who have cancer but have not had it detected yet, whereas these studies are done on people who have had their cancer detected already. So it's not like inherently the same population, but like similar. So we wanted to write that somehow.
Yeah, well, that's not how it's written. It's just the case control studies. So I guess the performance of the study is better evaluated in population studies than case control studies, where we where there's more higher prevalence of clinically overt or clinically evident diseases than clinically asymptomatic diseases. So there's that difference you want to mention.
Okay.
In real life, we want to, find patients who are asymptomatic but have disease. But a lot of case control studies will evidently have a lot of symptomatic cases, which could translate into higher stage or further advanced stage cancers. Um, so that, yeah, that is something, not a limitation, but that's just how the studies have been done because population studies are more expensive. Um, anyway, again, I mean, yeah, like just put it in that way that I just said. Like it's ideal to have more population studies, but you know, case control studies were majority, and you know, they tend to have more symptomatic cancer patients than asymptomatic cancer patients, and that might introduce cohort a study structure, or they might introduce, well, I don't know what to call it, that might introduce,
A propensity for higher stage cancers. Or
yeah, but eventually how would that negatively affect our credibility? It wouldn't affect our credibility for sensitivity specificity, but you know, I guess the performance would be eventually different depending on what type of studies we analyzed or something. You know.
okay, yeah, we can change that, the general idea.
Yeah. So when you say many of larger studies, some other recent reviews, you always have to cite them, everything. If you want, if you're referring, yeah, put all the, you know, doesn't matter if it's 10 papers, they put all the reference here. So, but these kind of sentence is redundant. You know, all the reviews will be similar. You don't have to say that. And you don't have to say that, you know, these large studies were already discussed. You just say, you know, compared to the prior literature, we include the largest number of, yeah, that's it, you know. I guess you're gonna put reference here.
Yeah, those are the studies you're going to refer to.
Okay. So why is this the point? Similarities?
Like linking the like the other studies didn't have like a discussion section where they like wrote like, oh, like the two like studies who use this platform, like they didn't exactly like group studies together and like compare similarities between them, whereas in our results section we did. We have like the narrative part.
Similarity. So what is the similarity we're saying?
Like kind of drawing parallels between the studies and that like, you know, like we'll group the like blood cell extraction based assays in one section, and then like write like, you know, both of these studies use peripheral mononuclear cells in their paper like that.
I see. Uh, that's kind of, you know, in the eye of the beholder. because one might say you could have microRNA, it has to be, some might still argue like whether it's all extraction based or not, whether it's from platelet, PMNN, or tumor DNA, tumor circulating, it's still RNA, whether it's microRNA, RNA, it's RNA. So one might argue it's like RNA technology, RNA sequencing. RNA is a DNA and RNA is still nucleotide. So you could still say it is you could just lump them together in DNA RNA sequencing based, genome transcriptomic sequencing based. Whether it's cell extraction or not, that's just the technical difference. So how you group them together, I'm saying it's all arbitrary, but to me, DNA RNA based makes more sense than where it's saying where it's coming from, platelet or blood or white blood cell or wherever that is. Anyway, I'm just giving you a counter argument. Similarities may be arbitrary to reviewers. So I would say we, rather than focusing on differences of these assays, we grouped different technologies into 4 different categories, and compare the performance of different assays. Something like that. And when you say similarities, they're not similar at all. So I like that wording better. The other thing, going back to my first comment about the protein and the DNA, is that a lot of assays are, Cancer-Seq is also, prime example that it's DNA, but it's also, it's methylation, and then I think it's sequencing. There's DNA methylation, and there's also protein biomarkers. Am I right?
Yeah, all 3.
Yeah. So I would say, you can still put that in DNA, but I want a separate paragraph or something after that 4 categories saying, we want to emphasize that the future is using different platforms altogether, because they are, the terminology is orthogonal or independent of each other. And by putting these multi-layered tests using different omics, the sensitivity and specificity will only increase in many cases. So, and of the papers that we reviewed, what are the ones that used more than 1 platforms, in that 4 different categories. And Cancer-Seq is one of them. So you can double mention it there. So mention that the main performance in the main platform section, but also to be more strict, it should also be mentioned in the combinatorial platforms. And one can look at, one platform-based technology versus, dual or multiple platform assay, group them that way and see, compare the performances that way. And that might make a point. So yeah, maybe do that, and maybe Eugene can help design that multi-omics versus single platform. That could be a separate graph and a conclusion in this review.
Okay.
Okay. Okay, policy implications. I like this. I like to have, a couple papers discussing this ownership, like any review papers, anything that discusses this issue quoted here or referenced here, okay? I would say many practical aspects here. Economic cost of this. Yes. Okay, this is pretty general, but well written. It's fine. Grand and exciting future. For a review paper, this is kind of the, I guess, I think this is kind of at the limit, but I would still okay this. Okay, I think this is pretty general. Now, I think what I so in the discussion, I don't see anything about ongoing trials. There's no paragraph about, in the ongoing trial, what is being addressed there.
Oh yeah. So I wrote a table about like current trials that are ongoing. I didn't write about it though. I just like mentioned that like there are a lot of ongoing studies. Do you think I should write about that?
I think you have to write about it because, yeah, and then put in the parenthesis, look at this table.
Um, should I focus on some like very particular studies or like in general, like what are those studies looking at and
More general trend,
a general trend? Okay.
are those large ongoing studies are mostly DNA? If the answer yes, then yes. Are they combinatorial? Are they only DNA? Are they general population? Are they certain age group? Are they higher risk group, like smokers? Are they um, well, I guess the positive results would lead to approval of the assay or something.
Mhm.
Uh, like, what would be the foreseen impact of the study if it becomes positive or something? And more like a general bird's eye view of ongoing trials. One paragraph about it, about that, and then, cite it.
Paragraph. Okay. Yeah, I could talk about like the NIH like funded or like the NCI trial too. Yeah.
Yeah, because that's we talk about stakeholders, right?
Mhm.
And then the conflict of interest bias. I don't, is that the right term? It's a bias caused by conflict of interest. Who is in the best place to minimize that? Government. It's Medicare, it's coming out, Medicaid, those are coming from US, tax, right? Taxpayers' money. So someone has to take the responsibility and say, this is the better test worth our tax money. And this is the ideal cost the society is ready to pay for. And the government is ready to step up, because if we detect cancer earlier, then the cost of surgery, chemotherapy would be lessened. Right? It's much more than the cost of DNA test. So yeah, I think the government-led effort, you should describe what that is and put citation and everything about it. I think that's important.
Okay.
Okay, so are these table final? Where's table 1? This is figure 3.
Oh, table 1 is in a separate document. I can send it though.
Okay, so is it? So where's table 1? Well, I'll look at figure 4. Where's figure 1? There's figure 3.
Figure 1 is I think in the job talk PowerPoint too he had. That's the one where it's like we had this many articles and then we like filtered down to this many and then we like
Okay,
yeah.
what is flow chart?
Yeah.
Eligibility criteria. Why is this figure? And does Lancet allow many figures? What's their limitations?
I'm not sure about that, but I
Oh yeah,
guess
look into it, and usually if you don't have, this one is okay. Summarization, okay, this one. Is table here in this document, or is it separate?
no, they're not in a document.
Okay, just show it to me in next meeting.
Okay.
I'll just start with the figure 3 then.
Mhm.
It's better to say it here again. A, sensitivity, B, oh, it's here. I'm sorry. It's not clear because it got cut off here. Sensitivity, you see the word sensitivity is cut off for
Yeah.
whatever reason. You should remake the table. It doesn't, the B shouldn't be here. I think you have to remake the panel. And bold letter sensitivity, specificity, and odds ratio. Okay, here you have the platform name. Here you don't. I think you have to be consistent. So I would put, for convenience, I would put it,
Would put it, okay.
yeah, put the other platform names. And also make sure you use the exact commercial trademark. Like, Penseer, is that all capital? Like Delphi is all capital, or is this how they, in the gallery, is it, like Garden Health is a company name. Garden 360 is their platform name. So I want you to be exact. Like, is it a company name? Is it a platform name? Go by the exact product name, the platform name, and use, if acronyms, the capital letters, like just like the CancerSeek, so it's a brand. So use the exact brand that they are using for their product. Okay, so there shouldn't be any mistake, because the company will be angry if we don't do justice. Okay. Okay. Here is the DNA-based assay. Do you know why we did it only for DNA? And it should say how many so do you have footnotes on each figure?
I don't know if they were included. Some of them do, but
So every image should have footnote describing all the method, what you actually did, and all the acronyms. AUC, comma, then area under the curve. You have to have footnotes for every image. NA, what is NA? I'm not sure what this is.
oh, I think one study only reported AUCs and not sensitivity or specificity, but it was ctDNA based. So they wanted to include it, I think.
I mean, that's fine, but you have to follow the same format, what year and
Hmm.
there's ZO here, there's NA here.
Yeah, I'm not sure.
And the reviewers might think, why is this different? And you have to explain in the footnotes that the studies that had since that original number were some why these studies were selected, and why the selected groups are different. It can all be explained in the footnote. It doesn't have to be in the method nor in the text of the actual manuscript. It's all in the footnotes of each image. Okay.
Okay.
The footnote is not image file. It's separate text file. So the best way you have the title in Word manuscript format, and then image, and then right below the image, you have the footnote. Same thing here, you took out the et al to create more space, which is fine, then follow the same style. Has to be consistent, okay? I would put control it like middle space, middle position it. In the footnote, same thing, or is odds ratio or something. So again, non-DNA based with cell extraction, based. You have other categories, and why are you presenting only DNA based here? If you want to present other methods, then it has to be figure for A, B, C, D.
Yeah, I think this is all just from our meta-analysis on the 10, like just cfDNA based assays.
You can do non-cfDNA based assays and do another curve. I mean, I don't want, you have to be fair. You have to, present everything. And also, if you are kind of limited in presenting what figures to present, this could go to supplemental too. But I would say, don't just do cfDNA. I would do, just like you're pulling everything all together, I think you need, if you follow the same footsteps, you do all MCED and then do 4 different categories, ROC curve. So that's 5. Just be consistent.
Yeah, okay.
Accuracy. So cancer type and so this graph doesn't tell me what the difference is, A and B. Accuracy of cancer type prediction. So think about this. It's like you have cancer, and are you predicting what type of cancer patient has? Or you don't know if patient has cancer or not, but then you're saying, whoa, I detected breast cancer. I detected lung cancer. So detection of cancer comes first, and then are you accurately predicting, certain type of cancers? So I think the better wording is not type prediction, but it's the cancer prediction by type. Because you're stratifying the data. So you have a data from multi-cancer cohort, and then you're just separating out each cancer. So, you know, in which cancer did the cancer detection rate highest or lowest? You know, you can argue the breast cancer was lower because you have so many stage 1 breast cancers detected by annual mammogram. Not just because they're low shedders, but there may be low shedders because of so many of them are stage 1. Now I have 2 stage 1 breast cancer patients in my clinic. Just saw another one yesterday. So you could argue that the detection rate is lower when you have a effective screening tool that enriches asymptomatic, low disease burden patients. Okay, so you can put that in the discussion. Anyway, yeah, I think people are going to better understand this figure by wording it differently. Accuracy of, and in the method so I think we have to, although this is, I think, epidemiology 101, like how did we calculate accuracy? I think in the method, it's better to write it out. Okay. Maybe, and then even if you wrote it in the method section, still write out in the footnote section. Footnote accuracy was defined as some, you know, oh, what was it? Sensitivity plus specificity divided by something.
Yeah, some formula.
Yeah. Arnie knows. Arnie just took the test. What is it, Arnie?
Sensitivity or specificity?
No, accuracy.
Accuracy. It means that if even like in another test, it will be like the result will be still the same. Like even like you try it a couple times, it will be like showing the kind of same result. So it's the accuracy is good.
It's
Like
not, it's like reliability of the test.
yeah.
I actually do kind of have to go to class, and there's like a mandatory 1 at 10 that I can't skip. So
Oh, okay.
kind of have to go now. But
Right,
yeah,
yeah,
I was
you
thinking
you
those-
can listen to my comments because this is recorded, so.
Okay, yeah. All right, bye.
Bye. Good job.
Thank you.
Okay. Let's see. Now for all your learning. Why it doesn't go down? I'll show you. Accuracy. So here. TP. Oh. Why is it? Precision, there's a precision. Where's the formula? Precision here. Here's the accuracy formula. So combine everything all and true, positive, true, negative. Percentage. This is how you calculate accuracy. Okay. So it's the percentage of true, positive, and negative, you know, among the cohort. In case you don't know, but some of the readers will be perplexed by what is accuracy. Like they know sensitivity and specificity, but so it's better to always write it out. So here, A, you have to have a title for A. So this is all type combined. And this is cancer type prediction. So I don't understand the graph A. This is all cancer detection, I think. But then here it says accuracy of cancer type prediction. So are these numbers same? Well, I guess accuracy of cancer prediction. I don't want to say type here because it's not, it doesn't mean they're predicting the correct type among cancers. This is the accuracy of saying this is cancer or not cancer. Do you understand? And this is now just, we're talking about ovarian here. There's breast here. So here the breast accuracy is not bad. Yeah. I don't like gray here. It has to be bolded. Or underlined, whatever. Cancer type equals ovarian. You don't need equal here. Say ovarian, liver bile. That's all you need. And then bold it, underline it, whatever you need to do to highlight it. So this is accuracy of cancer prediction by cancer type. Again, it's not type prediction. It's not given. The type prediction is only relevant, appropriate if you give them all different cancers. So you don't have non-cancer. You give all different cancers and tell the test to figure out what type of cancer it is. We're not doing it. We have so many non-cancer in the cohort and saying, find out if this is cancer, and if it is cancer, what type it is. But it's really cancer detection by type. Okay. Forest plot of sensitivity. So same thing here, bolded, or I don't like the gray letter here. I don't like equal here. Stage 1, 2, 3, 4, And you have same thing, no cancer type equals just colorectal, lung. And in the footnote, we have to say why we just selected these types. 1, 2, 3, 4, 5, 6 types. Based on the most common or based on what? What's availability of original data? Whatever that is, it has to make sense. They shouldn't think that we randomly selected these. And again, we don't have to write that in the methods, but footnote is fine. So for stage, the trend is pretty clear. And this is what we found from our analysis. And I think in the discussion, we have to write this clearly that when we, because this is only possible by getting the original data and doing the meta-analysis. And by study it, the trend is clear that as the stage progresses, there's a higher sensitivity. But for the cancer type, the sensitivity wise, if you look at, the gastric, it's different. If you look at lung, it's, even down 0.6 versus higher in colorectal. So that those, by cancer type, what have we seen? Not just say it's different, but what are the trends that we've seen? I think this was what's lacking in the discussion that I'm sure this was described in results, but I feel like discussion is where we go in depth. So I'll tell you the rule of thumb for these papers. Being in graph or table doesn't mean you don't write it or you've done your job presenting the data. You have to write it out in the text. Whether and in the text is what you need to have readers go to the table. Put the table number there after the paragraph or the sentence. And that has to be always in the order. Like in the text, you cannot put table 2 first and then go to table 1. It has to be always in the order. Summarization of subgroup analysis results from meta-analysis. Make it smaller. I'm not familiar with sense and spec. I would put sensitivity, specificity if you can. If you have to make an acronym, I would do 3-letter SEN, SPE if you have to do it. And always do, footnote, and SPE stands for specificity, things like you have to write it. I would not middle space it. I would space it to the left side. And you can use bold letters for the categories. I don't like 3 digits. Make it all 2 digits. 0.70, 0.57, 0.81. Okay. It's too much information. This is probably exception. But for these, you can make it 2-digit. And same is true for any number that's presented here. Any number in the table, figure, main text. Okay, supplemental figure. Subgroup analysis on study type and gender of population. So I would write, I mean, it's in the graph, but I also you need to write it here. A is for by gender. Okay, I want title to be in the graph as well. And it feels like it's all crunched. A should be part of the graph and the title. It shouldn't be, like it feels like it's in the between. So I don't like the design, how you made the panel. Like it has to be a separate graph with all the title and subtitle inside. And there should be a space in between the 4. So gender difference. So this is also gender. And sensitivity, specificity. This is stage difference. So you have stage 2 and 3 here. 2, 3, 1, 2, 3, 4. And you have sensitivity, specificity. It kind of overlaps with what you did on the accuracy. In the stage here. So here you only looked at state sensitivity. And type. So I think you have to be consistent. If you're gonna show it, you're gonna have to show it all. So Arnie, work with Eugene. This is sensitivity. Then you need to show specificity. This is sensitivity. So figure, either you make figure A, B, C, D, or if it's too much, then you put it as a supplemental figure for specificity and show it to the readers. Because you have sensitivity and specificity here in the same graph, in a different category.
So do you mean we need to separate it between the sensitivity and the specificity? Like make it into different parts?
I'm saying that in an ideal world, A, B, C, D, with CD being specificity is what's ideal. But if there is a limitation of space, then I would rather encourage supplemental figure for specificity of the stage and type analysis.
Okay, I think I get it.
Okay. Oh, this is here. What I just said is here. So I don't understand why supplemental figure 1 is here with stage 1, 2, 3, 4 being combined. And then you have another one with 1, 2, 3, 4. I know they're different grouping, but it almost feels redundant. Maybe because some studies have lumped them and there is no way to unlump them. I don't know. I need an explanation. And probably reviewers want explanation as well. Like, why am I showing two different graphs here? Stage 1, 2 combined, 3, 4. I mean, there's a value, but look at the, space or figure limitations, and we have to show either one. I know it's supplemental figure, but sensitivity, specificity, sensitivity. And here's the gender. In the footnote, the bottom line is I want you to describe whether some papers you wouldn't were not allowing us to do analysis by exact staging 1, 2, 3, 4, but rather if they presented their data in the format 1, 2, 3, 4, we have no way to separate them, then and because of that we were doing pooled analysis for that reason, like Valencoin, Luo, Klein. It seems that you did separate everyone here. Okay. So you look at this. Female, male, they're all different studies, but they're, stage 1, 2, 3, 4. And here, stage 3, 4, 44. Hmm. So I don't know if for the specificity, events mean true, negative. I guess that's how the meta-analysis report specificity. Just check, I'm just blinking what other papers have done. So Arnie and Liam, look into other papers. For sensitivity, accuracy, it's fine. But just to see if events can be still used. Because you feel like event is cancer, event is something that's detected. But in specificity, it's the opposite. True normal or something true. I don't know. Just look into other papers. I'm not sure. Okay, so next time, make it into a real publication quality with good footnotes and tables. Tables will have footnotes as well. Any acronyms, anything you used, you need footnote. Okay, so use that. So I want publication quality with good abstract for the next revision. Let's get it out before other groups will publish something similar. So next week, I do expect a full publication quality manuscript with revision done based on my comments today. Okay, so we'll wrap up this project for now. Let's take a 10-minute break.
Thank you,
And
Dr. Che.
Okay, you're welcome. Okay. Okay, there's no echo. Let's resume. Who wants Arnie? Update from you.
Okay, Dr. Che, the update, I think for me right now, there is like four projects under me right now, like outside the cancer screening. So okay, I will share my screen from the laptop. So basically for the Yunho paper, actually me and the others like kind of want to ask about this because the Yunho paper is talk about modified Sada-Busit, right? Like the for the hyperprogressions, we want to make a paper about modified Sada-Busit. So my question is like, wait. I will share my screen. Okay. So for the Yunho paper, actually, like, do you think we still need to do do you think like, is it worth it to collect the 180 patients again from the start for the Sada-Busit, modified Sada-Busit, or for my own sample, is it okay to that I can add the modified Sada-Busit into my paper or into my manuscript?
So I don't understand. Go back to the background. Like what's different between you and
My paper, like we're talking about already like making the manuscript like the paragraph I want to talk actually.
So
So
I know we're talking about your project, but there's Dr. Jian
yeah,
knows nothing
so
about the project.
there is
When you
so
say
there is the okay. I will
topic, what the differences in the theme?
okay. So basically, there is like one thing that I kind of considerate about Yunho's project, or like the hyperprogression, the first one that I get the manuscript, the Dr. Jian project, like the one that from Yunho.
Clarify. Talk about the title of Yuno project and the title of your project, and talk about the difference.
Okay, for my project, we take from the 300 samples that you gave it to me. We count the RECIST criteria, and we talk about the 5 definitions of the hyperprogressions for my sample. And we take 130 samples that we can make it into its definitions. That we use 3 definitions for this project. We will talk about the incidence rate for its definitions, and also the the downfall of RECIST criteria per definitions. That's what my project talk about.
So what is the title of your project?
I think I will make like the different, like the hyperprogressions incidence for definitions.
So hyperprogression instance by different definitions.
Yeah.
And you looked at lung cancer only.
Yes, lung cancer only.
And there's a difference in population size, your paper and Yuno's paper?
Yes. So my sample is 130. Yunho's sample is 300 samples. Why it's different? Because for my paper, we need to count the RECIST criteria. So there's only 130 samples that available for to us to count the RECIST criteria. But because Yunho paper only talking about the definitions of modified Sada-Busit definition for hyperprogression, they doesn't need to count the RECIST criteria. So they have more samples.
Modified Sarabujid does not
Yeah,
require resist.
yeah, exactly. This is Yunho manuscript before.
Incidence and risk factor of hyperprogression in non-small cell lung cancer patients. And this only use Sarabujid.
Yeah, the modified Sadabuzid one.
For
They
those
with
who don't
Mhm.
know what that is, can you explain that?
So the Sadabuzid, where I will take the press wait, the PPT. HPD. So basically, it's quite simple. The modified Sadabuzid, it's only taking like the. I'm sorry, where is it? Yes, because Sadabuzid, it's really easy. That's only counting TGK and TGK reference and minus reference more than 2. Minjong make the count of the paper also for the radiomics. It's not hard, so they doesn't need the RECIST criteria. That's why they only use this one for the
No.
Yunho paper one.
Go back.
Yes.
Go back to the table. Now, all 5 definitions written here require at least 3 sets of CT scans, correct?
Yes. Yes. Especially the RECIST one. Yes. Yes. 3 CT scan.
So explain to me why has 300 and yours is only 130.
For me, when I did the TG, when we recheck all the data, we find many CT scan that we cannot find. We cannot find like there's like loose like because we use like what we talked with Minjong before for counting the other definition. They have like less than 1 month, more than 2 months. So many samples that we filter it out when we try to collect like from 300 to 130 sample for me. But also the radiomics data, actually I realized at that time that the counting is made like really different. I cannot really little bit understand because before they, where is it?
Okay,
So this is like the TKR ka.
that's not
So this is like the TK.
so what do you mean by radiomics data? Is it hyperprogression data? Is it different?
Radiomics, I don't know. Since the first time I get this table from Eugene, or the title is radiomics. It's like the combination sample of Yunho sample and stash sample. From that sample is the one that me and Zuni tried to collect the data at that time.
So if you don't understand that, I don't understand either. I want you.
But
very-
for yeah, okay.
So my point is this. Whether you're able to do resist or not should not be the difference between 130, 300. Either the initial data created by Yuno or Hyunsun has a flaw, that it doesn't meet the initial criteria to be able to assess hyperprogression. If that's the case, we should not go by 300 because that 300 includes a lot of ineligible patients. If that's the case, we should stick with 130, and Yuno's paper has to be modified to 130.
Okay. Okay.
Eugene and see what Eugene and Yuno and see what's the truth.
Okay. Uh,
And the next question,
that's the question.
two separate papers? Or does it have to be combined? Are we trying to send different message? Or are we trying to send similar message?
So basically, the things that I want to ask that because like papers before talking about modified SADA busit with 300 sample, you want that that explanations or that manuscript also put it in my manuscript because I also use SADA busit.
So who is publishing Yuno's paper? Is Yuno publishing it, or you publishing it, or Eugene publishing it? I don't know who's in charge of Yuno's paper.
Actually, it's me.
Okay, so in your eyes, does it make sense to combine both? It's same cohort. Is it different cohort? Then it makes sense we do it two different papers. If they are same patients, it makes sense to put it in the one paper.
Okay. For me, it's not because I don't want to collect the sample again, but for me, I think it will be better to combine it with one paper because this paper we're talking about hyperprogression in every incidence, and because we already discussed it like a couple months what we want to talk in the manuscript, I feel like if we also want to propose like new definition of hyperprogression, I think it will be really good to combine it in one paper.
Okay, then decision is to combine it. We discuss about different abstract. So one paper can have 5 abstracts. It might have different points, like by definition, by cancer types. But if we are talking about one cohort, has to be one paper with different bullet points to highlight, okay? So sure you combine it, okay? And make sure you have Eugene and everyone involved in this new
Manuscript.
and
Okay.
any project you have to decide on the title. Title is the core, the theme. You have to know, and when you discuss your project, not just Arnie, always present with, this is the project we're looking at. This is the goal of our project, and we're looking at, with that goal, we're looking at this data. Don't just jump in and into details, okay? Now, I think without title, you can't do anything, but I think you had titles for the abstract that was already submitted. Do you have those?
Yeah. We already, when last time we submit 3 abstract for CC. For my data, from there we have 3 abstract.
So when it CC result come out?
Liam, could you help me?
Yeah, so we don't know that. They don't give us a date, like a specific date where they say if they're going to post results. We're just waiting for them to send out emails.
So last time we published the first one, understanding the definition of hyperprogression disease and its incident. The second one, we talk about the risk factor for the hyperprogression in lung cancer patient using 2 different definitions. And we talk about the overall survival and the progression-free survival. For the 3 abstract that we made last time. And so for the manuscript, I think like I will take like the one like making like the definition of hyperprogressive disease like by its incidence. But I also want to talk about the risk factors because we find like 3 risk factors that quiet effect for the hyperprogression disease and the OS and PPS actually.
So let's do the incidence of hyperprogression by different definitions.
Mhm.
And its risk factors. In non-small cell lung cancer.
Yeah. Actually, for the manuscript itself, I already like kind of make the bones of the manuscript, like what I want to talk per paragraph, because we already have the result that we publish in the abstract, and I want to discuss it with Eugene and Liam after they're back. Actually, because if it's already okay, we want to start writing the manuscript from the abstract. This one like still like the skeleton of the manuscript that I made. Do you want to see it like for the discussion part, or you just want to wait until we already tried to make the manuscript?
No, I think we can get feedback from you, Dr. Che, today if you have any thoughts.
So before we get here, show me the result. Graphs or tables, whatever what is the take-home message of this article? From that, we'll figure out.
Okay, for the I think this the table like. Okay, for the first, I will take it from the abstract. Then I will just tell you so for the incidents that Eugene's already counts, that we have actually two type of table last time. The one the total sample that have only single regimen, like single, that only go with first time immunotherapy, and also some and also 144 total sample with multiple regimens, like they have like immunotherapy like twice or three times, so we put it in 144 total number of regimens. And like I told you, we only use like three definitions: Champion, Sadabusit, and Ferrera, because we didn't use the other one because we cannot count the pace. And from that, we have like in the incidents, of course, like, and usually like Champion is like the best one, like the one which show it to you is 7, and Sadabusit 14, and like Ferrera is 0. But we modified it, as you remember, that the tumor lesions, we add up the total number of the new lesion to the target lesions, whether it will be changed the incidence rate or not, like the one that you just asked before. Can you hear me? Okay. So from that modified lesions, that the new lesion we added into the target lesions, the incidence is changed, like into like 16, 21, and at least like 9 for the Ferrera, like from 0 into 9, because we add up the new lesion to the target lesions for like the one that you suggest us before, like should we have like a different RECIST criteria only for hyperprogressions. So that's the topic for our first one that we want to put it in our paper. And the second one, the risk factor that we find, also using like two pools, the one with like only like single and double. And we got that the most risk factor that we have in this, the really one that the only 3 risk factor that affect hyperprogression is like bone metastasis, non-adenocarcinoma histology, and immunotherapy only regimens were associated with hyperprogressive disease. That's the only 3 risk factor that we get from all of this, like immunotherapy, histology, PD-L1 status. Actually, for the number of the metastasis, we want to recheck it again, because last time there is some little bit of miscommunications about the metastatic. We want to find the metastatic when it's like the first time we start the immunotherapy, or like after immunotherapy, or at the general one for the metastatic one, because like metastatic is also keep evolving, right? So that's why we think that we should like to collect it again for the metastatic, and we want to make sure it's better to pick the data when it's like starting the immunotherapy or like after immunotherapy, and like within 2 months for the metastatic criteria. And for the OS and PVS, yeah, so both definition were associated with words OS and PVS, like usually. That's also it's being count with the hazard ratio last time with Eugene, and the confidence interval is quite like the p-value is like less than 0.1. So for the survival rate and the progression-free survival, they're also associated with worse for the hyperprogression disease. I think for me, when I collect this data and seeing this analysis, I quite happy because at least there is a correlations that we can talk in our paper.
Okay, so you should combine it all. You should emphasize all 3 points. And yeah, I think it should all be discussed. So let me go through the
Okay.
so suggestion will go up. All right.
Yeah, for me,
Then definition, limitation, main risk factor, main known risk factor. I mean, so you don't have to. So here is like introduction. Like you don't describe the details. So it's save everything for discussion. Why is it
okay.
new definition? So you don't have to have OSPFS hyperprogression. You know, what's the clinical implication? Like people with hyperprogression tend to die sooner, tend to, you know,
Mhm.
don't do well with further subsequent therapies, things like that. That's why we need to understand who they are and whether we need to design a upfront fully aggressive or upfront most aggressive or full force or more combinatorial regimens upfront for this particular group that this group of people who are predictive of having resistance to immunotherapy. Let alone not just the resistance, but hyperprogression, which actually makes them die sooner or have more metastasis. So it's more about talking about the clinical implication. Why is it important to identify them sooner than later? So that should be the topic of the discussion, introduction. Okay.
Yes, Dr. J.
Perspective 128. Okay. Risk factor table discussion. New them. So you know, there's an order to it, like discussion. So I tell you guys every time in my Zoom meeting for any manuscript writing, there's always logic. Follow this rule. For introduction, read the title 10 times. Now, if the title says incident, okay, why is it important to know? What is the instance hyperprogression? You have to write it. What do we know so far? What's the current knowledge? And what is the current definition that's widely used? What are the current risk factors? So the current knowledge, introducing them, people may not know what the term hyperprogression really means. So introduction of the current concept, number one. Number two, where is the knowledge gap? Where do we want to be? But why aren't we there? In a perfect world, we don't want hyperprogression. We don't want to kill patients sooner. We don't want to kill a patient by giving our therapy, but we are doing it because we don't know why there is hyperprogression and what are the risk factors and how prevalent it is. We don't know. So the knowledge gap is we don't really know the risk factors well. We don't know really the the true mechanism. There are proposed mechanisms. We don't really know the true prevalence that well. So because we don't know that well, we don't know how to prepare, how to reverse it. We don't know how to select those patients who will have progression and not give immunotherapy for those patients. So so that's the unmet need. So we have no way to intervene. We are helpless. Arnie, you like the word helpless, right? We're helpless.
Yeah.
So
Yes, Dr. Che.
talk about the knowledge gap. And then what are we doing to bridge or minimize that knowledge gap? So we decide to look at our own data set. We decide because the data is so different, like by definition, we decide to look at all the definitions. We decide to propose our own definition. We also wanted to look at the risk factors. What have we done? So it's always the three-part: current knowledge, what is the knowledge gap, and what are we doing to minimize that knowledge gap? So make sure there's that clear logical flow with introduction. This pertains to any paper, any medical writing. I need to see that flow. If it's just like so many words and there's no logic there, it's hard to read. For discussion, same thing. Why did we write this paper? So I always want to see the first paragraph saying, in summary, or like in short, what is the take-home message? Don't wait till the last paragraph. Just say it. In the discussion, we found so. Compared to the current literature, this paper is unique because we're the first one to show this and that. I think there is no paper that applied 4 different definitions in the same cohort. Did you find that paper? No. We're the first paper to say we applied actually 4 different paper. We're the first paper to suggest the new definition based on all our experience. And we're the first study to do this and that. And this is the true clinical implication of our paper. Say that out in the first paragraph. And then you go, and then the second is, now let's talk about the detail. What did other papers found so far? What's the current literature say about our theme? And you discuss the numbers very much in detail, and talk about the instance in number. So compared to what the current knowledge is, then you say, but what we found is something different. And we found that by cancer type, by hyperprogression definition, there's a very big difference in hyperprogression. And this is why we think there's such a big difference. And then you say, each definition has pros and cons, and then we remember we said there are tumors that are like shrinking even before any therapy. There are some phenomena that the other definitions fail to catch, and without applying RECIST definition, if it was 1% progression and now it's 2.1% progression, which to our eyes doesn't look any clinically significant. So there has to be a clinical significance to it. There are factors you want to emphasize. What is the ideal definition? What's the new path forward? And you go each item, what makes it an ideal definition? And what do we do about the new lesions? And none of the criteria addresses it. No, it only uses RECIST criteria, not iRECIST. And even iRECIST requires one more scan for confirmation.
Yes.
But we don't want to require that. So go through details. What are our thought process? What do we really think in terms of coming up with the best ideal definition that we really need in terms of increasing the clinical applicability in the field? So talk about that.
Mhm.
And then you could talk about the, the strength and limitations, and then, ongoing. So what is actually needed. You could propose that for future clinical studies, we should strongly recommend that future clinical studies, clinical trials report their outcomes, not only as progression, but also report out using our own definition or whatever is widely used at that time to describe what are the percentage of hyperprogression in that clinical trial. So that no one has to, contact the author and, get original data and do another analysis. Let's make it our rule to really have that data for any pivotal clinical studies that are coming up. So you could suggest that in your discussion. What are as a medical community, what can we do better to better understand the true incidence and also better understand the risk factors associated with it? So I'm just telling you the general thoughts, the general logic, the flow that you need to apply to your paper.
Okay.
As I skim through the questions you've written here, they're pretty much all relevant here. But just to structure in a way that is, and then every
Yeah.
paragraph I like to have the theme sentence up front. Don't start with the Sada Buzid et al. Describe such, and wait for the main idea sentence to come later. Always start with the main idea and use the backup sentence to back up the idea. Back up.
Okay.
Okay, any other questions?
I think for my project, then I will revise for the manuscript skeleton, and I hope next week from Indonesia I will show you for the final one, because I really want to start this manuscript. It's already really ready because the data is being ready. Oh,
So
for the metas,
what was holding up your writing?
before I start writing, I want to show this, discuss this first, with Liam or Eugene, about the paragraph. But yeah, last time we still not have the time. So because I want to ask what kind of what we want to discuss for each paragraph, and also for the metastatic data, because we want to collect it once more before I left. Do you think it's better to take it the metastatic status when we start the immunotherapy, or 2 months after we start the immunotherapy?
What is metastatic paper?
The metastatic in here only shown in the bone metastasis, because we put 3 risk factors like liver, brain, and bone metastasis.
So what is your question?
Do you think we should take the metastasis data from the metastasis status when we start the immunotherapy, or in the baseline CT scan, or 2 months after the immunotherapy started? Because one thing that also quite interesting, there is no liver metastasis correlations. But as I remember, when I did the RECIST criteria, I still remember I count many liver nodule, or in per organ for RECIST criteria. But it's just funny that we don't have liver metastasis in the correlations. It's just a little bit weird for me.
So when we talk about risk factor, we don't go to 2 months after therapy, because that's not something we predict, that's the outcome, right?
Okay.
When we say predictive factors or risk factors, it's always the baseline.
Okay, Dr. Sri.
When we start the day 1 of immunotherapy, what do we have at that time point? So that's number 1.
Okay.
Number 2, So this is a new thing that you can look into with many students that you're working with. Percentage of new lesion popping up with immunotherapy. Who are those? Okay.
Mhm.
And what percentage of patient actually develop new lesion? Number one. And where are those new metastatic lesions? Okay, that will
Okay.
be interesting.
Mhm.
Want to know.
Yeah. Because I still remember when I did the RECIST criteria, I feel like there's a lot of liver lesions because liver is like the easiest metastatic and it's like quite big usually. So it's usually I count the RECIST for the liver metastatic.
And not all new lesions are hyperprogression. So, and then not all, well, new lesion is considered by RECIST criteria progression. So they are all in the progression. So I would suggest among all progressors, how many of them have new lesions? Okay.
Mhm.
Question is, among those progressors, what percentage is hyperprogression?
Mhm.
How does that new lesion group and hyperprogression group overlap? So it would be
Oh, okay.
progression, and then you have hyperprogressors, but then it's like
Mhm.
a diagram. There's the new lesion popping up group, and how many of them, and then you also know by looking at the overlapping among hyperprogressors, how many, what percentage of hyperprogressors will have new lesions?
Okay.
That's the third question. The fourth question,
Yes.
fourth
Mhm.
question is, without the new lesion, the first of all, apart from our new proposed definition, there's no the new lesion doesn't count in any of the 5 definitions, correct?
Yes, correct. Because they take RECIST 1-on-1.
Now, if we take the new definition that we came up, let's include new lesions, then among the hyperprogression that we defined by our new definition, what percentage of them are there because of the new lesion? You know what I mean? It's gonna be hard to
Oh,
it's gonna be let's say, so that you can only see that, let's say, just pick a one definition, Champiat, and Champiat has hyperprogression this percent. Now,
Mhm.
when you use same Champiat but add new lesion into the RECIST definition, then
Mhm.
what percent, what, how many, what is the percentage in, so that way
Yeah, I get it.
know how much is the new lesion contributing to the hyperprogression according to the new definition. So these are all good discussion points that you need to highlight.
Yes. Thank you, Dr. Che.
Okay. For
Okay.
those of you who are in the lab, I actually have something come up, so I have to drive to a different place. So we will wrap up the first part, but I will do the latter part in the afternoon. But
Yeah, because we have
do you have something else, Arnie, to discuss?
okay. Later is another project, but for this project, I think I quite understand from what you're telling. I will make another one for this one next week. Thank you, Dr. Che.
No problem.
Dr. Che, just a quick question regarding Arnie's project. So another question we did have was, Yunho's abstract has been submitted, but we realized that Yunho's data set had a lot of irregularities or inconsistencies. So we were wondering if you wanted to resubmit Yunho's abstract or if we can just leave it as is and just proceed with Arnie's paper.
What do you mean resubmit?
Like basically, do we have to redo Yunho's abstract and analysis? Because it is our understanding that he worked off of an incorrect data set.
So there's no place to resubmit,
Okay. So we just have to let it be.
right?
Okay.
And, you know, we do data cleaning and we find something to correct. Yeah, so everything has to be combined and we'll work on a new paper from now on. So, I'll see if I can, do, the afternoon session. I'll text you.
Okay.
And it's going to be probably after 2 o'clock.
After 2. Dr. Che, you have meetings in the afternoon as well.
Yeah. I'm gonna have to be coming into those meetings, so you should.
Okay.
Thank you, Dr. Che.
Liam, I will, yeah, and then so we can, and then you can resume,
Where is
Arnie,
the Zoom?
resume the recording, when the second session, starts, okay?
Okay, Dr. Che, I will stop. I will pause the recording.